In this video, we're going to look at a couple examples on how to find an inverse function. And these are going to be some challenging problems. So if you feel pretty good about how to find an inverse, or if you're in like a pre-calc or higher, then these would be some good examples for you to try. So remember, an inverse undoes the actions of a function. And if we input some value into our function and that output gets put into our inverse, we should get the original input as our final answer, right? So these are our steps in finding an inverse. We replace f of x with y, so we're just dealing with x and y. Switch x and y around in our equation, solve for y, and then rewrite it with the inverse function notation. So this example here, we got a lot of pieces going on here, and we have to remember that we're doing opposite operations and opposite order. So think of our order of operations as we're doing this here. But first we just replace f of x with y, and then we're just going to switch where x and y are in our equation. Okay, so now we've got x equals, and now we're trying to solve for y. So we have to get rid of everything else over here to get y by itself. So we need to do opposite order of operations when we're solving. So that means we're going to do add and subtract first, unless it's in parentheses. Well, there's no parentheses here, but the -1 is inside the square root with the y. So that's actually going to be our last step. This +9 is kind of by itself. So we get rid of the +9. So subtract 9 on both sides. Okay. And then the next step, and I actually like to kind of think about what's everything that's being done to y, so I can kind of plan out my steps in advance. So we're multiplying. We have the square root, or a cube root actually, so that's kind of like an exponent. This is the same as y minus 1 to the power of 1/3. We've got this -1, but it's inside this square root, so that's kind of like parentheses, and then the adding. So we got rid of the +9. Next step would be multiply or divide. So there is a multiply by 2, so we divide everything by 2. Delete that. And now that 2 is gone. So now what we have left is the cube root and the -1. So we got to do the exponent first. Remember, this is the same as to the power of 1/3. So we take the opposite of cube root is to cube something. So we cube both sides, or take it to the power of 3. Now we're almost done here. Last step is to add 1. So now we get y equals this here. And now I'm going to flip sides here and then change the y back to function notation. We get f inverse is x minus 9 over 2 to the 3rd plus 1. So remember to go ahead and pause these and try them yourself first. This next one requires a little bit more thought here, because we've got two variables, two x's, and we've got a rational here. So there might be a little bit more to this problem that may not be apparent right away. So try some different things, and if you get stuck on a certain step, kind of work your way through until you get to that step, and again, go one step at a time. So we change it to y equals, and now when we switch x and y, sometimes we think, well, there's two x's, so I don't know which one to switch. Basically, all the y's turn into x's, all the x's turn into y's. So we're not necessarily swapping them, we're replacing the y's with x's and x with y's. So now it's x equals 2y minus 3 over y plus 1. So this is a little more complicated because we want to solve for y, but there are two y's. So we have to somehow combine these. First, I see a fraction. I want to get rid of that fraction. So we're going to multiply both sides by y plus 1. Okay, so we get this here. And now I wouldn't get too hung up on trying to combine these y's. Just kind of think of when you're solving or simplifying, what are some steps that come to mind? Well, here I see parentheses, so I can think to distribute. So we get xy plus x equals 2y minus 3. So now we still have two y's, but it looks much nicer than what we started with this rational. So again, we want to combine the y's. So I want to get the terms with the y on the same side. So I'm just going to subtract 2y over to the left. And this doesn't have a y, so I'm going to subtract x and move it over to the right. Oops. Okay. So now we subtracted this over. We subtracted this over. Now we've got the two terms with a y on the same side and everything else on the right. Well, now here, hopefully you remember that we can factor a y out and put it out front, right? So we're factoring a common monomial, and now we just have one y. So that's how you can take something like this and combine those two terms to get just the one variable. And so now our last step to get y by itself is going to be divide by x minus 2, since these are being multiplied. We get y equals, and you see we've got a new rational, and that kind of matches up here, right? So we had a rational here, we end up with a rational over here. Now we change it to the inverse function notation. Oh no, I gotta delete this. Okay, and so we end up with this rational here. Notice how this looks a little different. I don't have negative x minus 3. When we're writing binomials, we like to have a positive x when possible. So since these are both negative terms, I can factor that negative out of both. And so this is the same as negative 1 times the binomial x plus 3. So this just looks a little cleaner. Okay. Now, I'm going to do one more slide here with the same problem if you want to look at it. And this would be if instead of moving 2y over to the left, we move xy over to the right. So it's going to look a little different, but if you went that way when you tried it yourself and you got stuck on how to get here, I'm just going to quick go over that. So we do the same steps here that we did before, get rid of the rational, and now we want to, again, get the y values on the same side. So let's say you subtracted xy over to the right and added 3 over to the left. What does that look like? So now we still have two terms with a y that we want to factor out. And so this looks a little different than the steps in the last slide, but it still works out just fine. We now want to divide this binomial so that y is by itself. But I hate when it does it. Okay. Again, we want binomials to have the x term first and, if possible, be positive. So if we just flip this around, we can write it as negative x plus 2. So that's what I have here. So you could have this, but again, it's kind of nice to have a positive x there. So we can change this to the interval notation, the inverse notation. But if we want to make this a positive x, this is the same as negative. Maybe I can draw it here. Negative x, if we factor out a negative 1, and this would be minus 2, right? But we don't want a negative in the bottom of a fraction, a rational. We like to have it up top or preferably in front. So now we can write this as f inverse of negative x plus 3 over x minus 2. And you see that here is the same as what we had this way.